All right, hello again. Hope you all are enjoying the classroom without me. Great. I don't really know what day it is for you, but I thought the meme was funny, so you can laugh at it. This video is over section 3.2, which is covering complex numbers. Complex numbers are fun. And so if we look at this chart here, what I realize is you guys really don't know how to define numbers necessarily. And so this chart does a really good job with it. A lot of what we've already been dealing with and what you've been dealing with for years are real numbers, okay? And real numbers are divided into two different categories, rational numbers and irrational numbers, okay? Rational numbers can be written as fractions, okay? Like a ratio, that's what a rational number means. So if it's irrational, it can't be written as a fraction. In other words, it's a never-ending decimal that can't be written as a fraction, such as pi. Or you could have Euler's number, which you don't know what Euler's number is yet. But just basically things that can't be defined in terms of a fraction. That's an irrational number, okay? But all the others are rational numbers. They can be defined as fractions. And then from there, you have things like integers. Okay, integers are anything from like -4 to +300. Just basically things that aren't fractions that couldn't be reduced to whole numbers, basically. And then you have whole numbers and then natural numbers. Okay, but what this section kind of gets into is imaginary numbers. And imaginary numbers live with the unicorns. That's a joke. You're supposed to laugh. Great. And the imaginary unit is what we're going to basically define today. And imaginary numbers are basically not real. That's why I had you say in section 1 that there was no real solution, because now we're going to talk about what happens if the solution is imaginary. Okay, so here's what you need to know. Not all quadratic equations have real numbers, solutions. For example, in 3.1, we said that x squared was equal to -3 had no real solution because we can't take the square root of a negative number. So to overcome this problem, we can use what we call I. And I is equal to the square root of -1. So basically what we're going to do is be able to write our answers in such a way where now we have solutions if there are negatives underneath the square root. Okay? And this imaginary unit can be used to rewrite the square root of any real negative number, okay? So this makes life a lot easier for us. It still doesn't really take care of the fact that things are imaginary. It just gives us a way to write our answers, basically. Okay, so let's look at how we can use it, all right? Let's see what happens when we square I. Okay, well, I is equal to the square root of -1. So if you squared I, well, you should know that squaring something and square rooting something, those are inverse operations. And so what that does basically is it just undoes each other and you're left with -1. So a lot of people will actually define I as a number such that I squared is equal to -1. You might see that more commonly than the definition I gave you. It doesn't matter because they both mean the same thing. Okay? So let's kind of play around with this. Let's see what happens when we cube I. Well, hopefully you understand from rules of exponents that I cubed is like I squared times I, right? Because you just add exponents when you multiply things at the same base. So hopefully you understand that. Well, we know that I squared is -1, and then it's I, and we can't really do anything with that, because you want to keep everything in terms of i's or numbers. You don't ever want to see a negative square root ever again. Okay? So I cubed is the same thing as -1i. You could also say that's just -i. Okay? I to the fourth. Well, I to the fourth is like I squared times I squared, right? We could agree that that's right. You just add the exponents to get to 4. Well, okay, I squared is -1, I squared is -1, and I squared times, -1 times -1 is just +1. So I to the fourth is +1, okay? This, by the way, is why we never use I as a variable, because some variables like E or like I have very special meanings. They are very specific. That's why you never see I as a variable. I mean, you could use it as a variable, but that's why you You don't see math books or math teachers using it. Okay. Okay, I to the 5th. Well, we can define that several ways, but the best way that I'm going to describe it is I to the 4th times I. Right? Because we already know what I to the 4th is. I to the 4th is 1. So it's like 1 times I, or it's just I. And what you will see, if you went and took I to the 6th, then I to the 7th, then I to the 8th, it's basically going to just cycle back. So I to the 5th is equal to I. Okay? So then I to the 6th I to the 5th is I. If you were to take I to the 6th, it would come back and be negative 1. And then I to the 7th would be negative I. And then I to the 8th would be 1. And if you went through and worked through that, it's just going to cycle through those 4. Okay? And you can do that if you feel like it, or if you're already bored from my voice, you can just take my word for it. If you're confused on this concept of I, all you need to understand, guys, at this point in the game, is that I is a way we can define negative square roots. Okay? If you're like, Baucom, you're crazy, what is this? There's a lot of really good stuff online you can look at for applications for it, but we're just not going to get into that quite yet because we're just trying to learn and have the basic understanding of I. Okay? Okay, so let's simplify. Let's use I now to simplify. Here's what I like to do. Okay? I like to deal with the numbers first, and then we'll worry about the negative later. So hopefully you understand that 25 breaks down into 5 and 5, because when we simplified square roots, we were looking for double things, okay? So you can pull out a 5, and what's left now is the square root of negative 1, right? Because you still got a negative under there, but we took all the other numbers out, so there's got to be a negative 1 still left. But you know that negative 1, the square root of negative 1 is just 5i. So that's all it is. So basically what's going to happen is whenever you see a negative underneath the square root, put an I onto whatever you got. Okay? That's the best way to describe it. Another thing I should remind you is that I is not equal to negative 1. A lot of times people say I equals negative 1. That's not true. I is equal to the square root of negative 1. Okay? Okay, on B, well, let's deal with 72 first. 72 breaks down into 2 and 36. Okay, and then 36 breaks down into 6 and 6, so we circle it. Okay, so now let's talk about the things that we can take out. We can take out a 6, okay? At this point, if there's nothing else to take out the negative. And when you take out the negative, it becomes an I. So for those of you that just like to memorize facts and not really understand what's happening, just take the negative out and put an I. Okay? And then you still have left underneath the square root a 2. Okay, an intermediate step I guess I could have shown was this, right? You could have said that, and then you could have taken the negative out as an I on the outside. So if you want to show that intermediate step, you're more than free to. Okay. All right, on C, if you look at C, you've got, oh boy, who's in trouble now?
Trayvon Woods, please report to the front office. Trayvon Woods, please report to the front office.
All right, beautiful. On C, we've got a couple negatives happening. So this is a really good example to show you that just because you have a negative doesn't mean now you're going to have an I. Because that negative in front of the 5 doesn't do anything but stay negative, okay? So you know that 9 breaks down into 3 and 3, okay? So we have a negative 5 already. We pull the 3 out, and then you're left with the square root of negative 1, okay? Negative 5 times 3 is negative 15, and then the square root of negative 1 is I. So that's where you can leave it. Boom, right there. Just like that. Okay? Stellar. Hopefully I haven't confused you too much yet. Let's do these next couple as well. Okay, we're here. Okay, so the square root of negative 4 breaks down into 2 and 2. That's a pair, so we've got 2 times the square root of negative 1, which square root of negative 1 is I. Great. Awesome. F is interesting because now we've got 2 negatives. So 36 breaks down into 6 and 6, which is a pair. So we've got a negative. 6 comes out from the square root, and you're left with the square root of negative 1, because there's still a negative in the square root, right? We haven't taken that out yet. But then the square root of negative 1 is just I. Here's your final answer right there. Okay? Okay. E. E is the square root of negative 12. 12 breaks down into 4 and 3, or 6 and 2. It doesn't matter how you break them down. You'll end up with the same thing. 4 breaks down into 2 and 2. Circle that. So we pull out a 2. I'm also going to take out the negative as an I. I hope by now we can do that. And then what's left underneath the square root is the 3. No, there it is. Okay. G. G is fun. Let's see, 54 breaks down to 2 and 27. 27 breaks down to 9 and 3. And 9 breaks down into 3 and 3. Okay, so we got a pair of 3s. And that's it. That's all we got a pair of. Okay, well, we had this 2 to begin with. So we have a 2. We pulled out a 3. Let's go ahead and pull that negative out with an I. Okay. And then we're left with 2 and 3. And I don't know if we've talked about this, but you're just going to multiply them on the inside. So we've got 6i times the square root of 6. And that's where you're going to leave it. Okay? Great. Hopefully I know I is still a relatively new concept and it's imaginary and you're like, hey, what's going on? But as long as you can use I, then that's really all that we expect. Okay? Beautiful. Okay, so now let's talk about what complex numbers are. Complex numbers, written in standard form, is a real number, a plus bi, where a and b are real, and A and B are real numbers, but A, this part right here, is the real part, and this is the imaginary part, which should not surprise you, because I is imaginary. So if something's attached to an I, it's probably imaginary too, right? Like the fairy that rides the unicorn is also imaginary. Man. Okay. Great. So let's see. If you have two complex numbers, such as a plus bi and c plus di, they're equal if and only if a is equal to c and bi is equal to di. So let's look at it like this. If you have, let's put that in terms of this. If you have ai, or a plus bi is equal to c plus di, okay, then you know that you can't compare, oh boy, what now?
Maylin White, please call extension 8000 or report to the front office. Maylin White, please call extension 8000 or report to the front office.
Okay. Like you remember how you couldn't compare like things with x's and things with not? Like you couldn't take 3 plus x and make it 3x. The kind of same thing's happening here. If this is imaginary, it can only be compared to what's imaginary, right? So that means that bi is equal to di, and you know that if you divide both sides by I, then you're left with b is equal to d. Okay, that's what this slide is telling you. If things are real, then keep them with the real things, and if things are imaginary, keep them with the imaginary things, and don't cross worlds. Okay, no matter how bad you want to go to Hogwarts, we can't. Okay, I'm sorry to disappoint you, but okay, great. Let's look at this. We want to find the values of x and y such that this is true. Okay, well, we've got here two things happening. We have an imaginary part. This is an imaginary part. And its friend that's also imaginary is over here. Well, you learned from the previous slide that if you have things that are imaginary, you can only compare them to things that are imaginary, right? So let's compare them. We can say that negative 7i is equal to y times I. And I'm hoping, I mean, if you couldn't see this right away, you could divide both sides by I and realize that negative 7 is equal to y, right? Because the goal of the problem was to find the values of x and y, so there's y. You didn't have to show me that work of dividing by I, though, by the way, if you didn't want to. And then you've got 2x and 10, so we set those equal. So 2x is equal to 10. We divide by 2, divide by 2. So then x is equal to 5. And you can always plug those in to make sure that you did them right, okay? But I'm really, really, really hoping that something like that is basic algebra to you right now, and we don't have to have that discussion very long. Okay? So here's some practice. Uh-oh. There we go. Okay. Find the values of x and y that satisfy the following. All right. Well, I like to circle them because I really like colors. That one's easy. Oh boy. X equals 9. Done. Gorgeous. Okay. And then we've got 3i and negative yi. So 3i is equal to negative yi. Okay, let's say we divide by I. So 3 is equal to negative y. And then hopefully you know to divide by negative 1. Divide by negative 1. So negative 3 is equal to y. Okay? Beautiful. On B, let's see. 9 is the real part. Over here, negative 2x is the real part. Okay? The only time we know that they're imaginary is if you see an I. Okay? So 9 equals negative 2x. Divide by negative 2. Divide by negative 2. I'm just going to keep that negative 9 over 2. If you wanted to change that to a decimal, you could, but I like fractions better. I think they're prettier. Okay. And then we can compare the imaginary parts. So 4yi equals 3i. Okay, well if there's a y on each side, or if there's an I on each side, and you've got 4y equals 3, divide by 4, divide by 4, y is equal to 3/4, and hopefully you know by now that just because it's a fraction doesn't mean it's wrong. A lot of people think that, not sure why. Okay. C, the real part is 4x and 8. So 4x is equal to 8. We divide by 4, divide by 4. So x is equal to 2. Great. Then the imaginary parts are 2i and yi. So 2i equals yi. I am really, really hoping that you can just see from that 2 equals y. But if you can't, divide by I by all means. Okay. All right. D. Here's the real part. Here's a real part. So 15 equals 1/2 x. I'm learning a lot of you don't know how to deal with fractions. You could do one of two things. You could divide by 1/2, but dividing by 1/2 is the same thing as multiplying by 2, right? So if we multiply both sides by 2, then this side becomes 30 equals x. You could also think to yourself, what number times 1/2 is 15? Well, 1/2 of 30 is 15. Okay. Then this is the imaginary part right here. Negative 3yi equals 2i. We can drop the i's. So you've got negative 3y equals 2. Divide by negative 3, so y is equal to negative 2. And it's okay, then it's a fraction. It's fine. Don't cry. Okay? Okay. As if that wasn't boring enough. Operations. Okay, well, let's see. To add or subtract complex numbers, you're going to add or subtract their real parts and add or subtract their imaginary parts, which sounds really complicated, but it's just the same concept of combining like terms. Okay, so now what we're going to do is we're going to treat I just like a variable. Okay, don't get crazy. Nobody's got time for that. All right, just combine it like you normally would. So let's go back to Algebra 1. Pretend I told you nothing about I. Nothing at all. Okay, and let's look at this. We're going to treat I like a variable, which I don't know. You might have this. This is just like it looks like a lot of like crazy things. So you can write that down if you want. But you should pause the video if you're going to do it because I'm about to move on. Pause now. Okay, great. Welcome back. Here's what this means. Ready? Let's see. For the first one, let's get rid of those parentheses. We don't really need them. So we've got 8 minus I plus 5 plus 4I. Okay, now pretend that I didn't tell you anything about I. What would you do? Well, hopefully you would just say, well, combine like terms. You've got an 8 and a 5, so that's 13, right? And then you've got a negative I plus 4I. Well, negative I plus 4I is plus 3I. And that is how you write it in standard form. A standard form is when you have the real part first and then the imaginary part second. That's literally it, guys. Treat it like a variable because it is a variable. It just stands for something else. And we're not going to really care about what it stands for quite yet. Okay? We just want to treat it like a variable. Here, we can't just drop the parentheses. We actually do have to distribute that negative. So we've got 7 minus 6i minus 3 plus 6i. Okay? We've got a 7 and a minus 3, which is 4. And we've got a negative 6i plus 6i. Oh, boy, that goes away to 0. Your answer's just 4. Woohoo, that's nice. And I know what you're thinking, Bacham, it cannot be this simple. And I'm telling you, I wish I could make it harder, but I cannot. Great. This one, again, you have to distribute the negative. Distribute. So 13 minus 2 minus 7i plus 5i. Great. Here we go. 13 minus 2 is a whopping 11. And negative 7i plus 5i is a negative 2i. And again, that is standard form. The imaginary part comes second. If you wrote it negative 2i plus 11, I wouldn't necessarily count it wrong. I just don't really like it. Okay? Questions? Not that I can really answer them right now, but I do like to pause and ask. If you have a question, I'm sure someone in class can figure it out. Okay, moving on. So guess what? To multiply complex numbers, you're just going to use the distributive property, or FOIL, just like you do when multiplying numbers. Okay, so again, treat it like a variable. It's going to be a really great time. If you haven't finished writing down these words, just pause, because I'm moving on. Okay, so treat it like a variable. Act like I never even told you what I was for. 4i times negative 6 is a negative 24i. And 4i times I, well, that's plus 4i squared, right? Now, here's where we do have to think like Algebra 2 children. We just learned that I squared is, well, let's go back. What is I squared? Where did my slide go? I squared is negative 1. Okay, so we know that. We know I has a value. So let's replace I squared with negative 1. So negative 24i plus 4i squared is negative 1, right? So you've got negative 24i minus 4. If you circled that, that's fine. I am going to put it in standard form, however, so that it's negative 4 minus 24i. Boom. Roasted. Done. So again, treat it like a variable until you see I squared, and then make an I squared and negative 1, because that is what I squared is equal to. Okay, on B. Distribute. This is might be where you pause the video and try a few on your own. I'm obviously not there to make you do it, but your choice. This would be a negative 15i plus 3i squared. Again, we have that I squared idea, so negative 15i plus 3 times a negative 1, which then gives you 15i minus 3. Let's write it in standard form, negative 3 minus 15i. I'm hoping this isn't too confusing. If it is, I'm sorry. Look them up on YouTube. I'm not quite sure. Okay. This next one we actually have to FOIL. I know some teachers don't like to use the word FOIL, but I don't really care right now. 9 times negative 4. Oh boy, those are really big numbers. I think that's negative 36. 9 times 7i. Oh man, plus 63i. Negative 2i times negative 4 is a plus 8i. Negative 2i times a positive 7i, well, that's negative 14i squared. Now, there's several things we can do from here. Negative 36 doesn't have any like terms, so we can bring that down as negative 36. 63i plus 8i. Okay, well, we can combine those, right? That's a plus 71i. And then I squared is negative 1, right? So then that becomes negative 36 plus 71i plus 14. And now negative 36, you can combine that with the 14, and we're going to write it in standard form. Negative 36 plus 14 is negative 22, and then we've got plus 71i. Okay, so that one is a few more steps. Not that much more complicated, but, you know, it's fine. We got it. Okay, C is really interesting. Can I show you what not to do? If you do this, I'm just going to cry. Okay, you cannot just distribute the 2. It's not how distribution works, friends. Distribution only works if it's on the front out here and it's being multiplied. But this here is an exponent. It means squared. And here's what the squared means. Okay, squared means 3 minus 6i times 3 minus 6i. And it's going to change your answer. If you just distributed, you would get 9 minus 36i squared. But that's not how this is going to work. Okay, so we go 3 times 3 is 9. 3 times negative 6i is negative 18i. Negative 6i times 3 is, again, negative 18i. Negative 6 times negative 6 is a positive 36i squared. And now let's clean this up a little bit. This stays 9. This becomes a negative 36i. And I'm just going to go ahead and change that to negative 36 if that's okay with you, because I squared is negative 1. So it changes that sign. Then 9 minus 36 is negative 27 minus 36i. Boom. Done. There it is. Welcome to the world of complex numbers. They're complex, obviously. Okay. One more page here. Here's why it matters. Here's why we learned. Because now you can no longer write no real solution. Now we can solve, because now we know how to define square roots of negatives. Okay. Okay, so let's solve. Well, we learned last section that you could either graph or square root or what else? What was the other one? I already forgot. What was it? Graph, square, or factor. Okay, well, hopefully you understand that this doesn't factor. Okay. And I really don't want to graph because, well, I don't know. So let's square root. So let's subtract 4, right? So you're left with x squared is equal to negative 4. Then you square root, and this is where you wrote no real solution, but now we can define this. So x is equal to, remember, anytime you physically take the square root of something, you do plus or minus. 4 breaks down into 2 and 2, so that's a pair. So 2, and then you're left with a negative underneath the square root, which just comes out as I. So x is now equal to plus or minus 2i. So from now on, you can no longer write no real solution. You must break it down and use complex numbers. Okay? Great. Okay, let's see. B. So many numbers. It's okay. Again, the only time that I really factor is if I see more than one x. And right now, because I only have an x squared, I'm going to continue using the square root method. There's nothing wrong with factoring if it does factor, but I just really don't want it. So let's get x by itself. Let's add 11 and add 11. So that leaves us with 2x squared is equal to negative 36. Okay. Then you can divide by 2, So x squared is equal to negative 18. So to undo the square, you take the square root. 18 breaks down into 9 and 2, or 6 and 3. 9 breaks down into 3 and 3. There's a pair, okay? So x equals plus or minus. You take a 3 out. There's a negative, so there's an I. And you're left with the square root of 2. X is completely by itself. There's nothing left to simplify. Do not leave it as a decimal. Leave it as exact numbers, and you keep it just like that. Okay? Beautiful things. C, again, subtract 121, subtract 121, x squared is equal to negative 121. You take the square root, take the square root. So x is equal to plus or minus. Well, hopefully you understand that the square root of 121 is 11. If not, you could use your calculator, okay? And then the negative just comes out as an I. So x equals plus or minus 11i. That's two solutions, by the way. Positive 11i and negative 11i. Two solutions. So if you were to graph these on a graph, what do you think would happen? I think, and I don't really know, I'm just a teacher, but I think that you probably wouldn't see them cross the x-axis, because that's what happened last section, and you wrote no real solution. So that's what's going to happen. So you know you're right. You know it's imaginary is if you go to graph it and it doesn't cross the x-axis. Okay? Okay, one more here. Let's subtract 25. Subtract 25. So 3x squared is equal to negative 66, question mark, is that right? Sure did. All right, we divide by 3, divide by 3. X squared is equal to negative 22. Use square root, and this one's interesting because 22 breaks down into 2 and 11, which are no pairs. So x is going to be equal to plus or minus. The only thing you can take out here is an I, because there's a negative underneath the square root, and you're going to leave 22 on the inside just like that. That's okay. Now, you have to simplify the radicals as much as possible, but if they don't simplify, then you can just leave them underneath. But make sure that you never leave a negative underneath the square root. Okay? Stellar. Okay, I've got 2 more problems here. Find all the zeros of. So just like last section, all you're going to do. The zeros of an equation are the solutions when y is 0. So we need to solve this. Well, that's basically what we just did, right? Okay, well, let's subtract 20. Subtract 20. So you're left with negative 20 is equal to 4x squared. Let's divide by 4. Divide by 4. So you're left with negative 5 is equal to x squared. Take the square root. Take the square root. Well, 5 doesn't break down to anything but 1 and 5, so you take out an I. Of course, you got plus or minus. You're left with the square root of 5 equals x. So the zeros of that polynomial, of that quadratic there, is plus or minus I times square root of 5. Okay? All right, one more. So we have 0 equals negative 1/2 x squared minus 24. I would add 24, add 24. So 24 equals negative 1/2 x squared. Let's multiply this by negative 2, negative 2, negative 48 equals x squared, square root, square root. And 48, I'm going to come over here and do it. 48 breaks down into 12 and 4. 12 breaks down into 3 and 4. There's a pair. So plus or minus, things that come out are 4. You can pull out an I because there's a negative. You got the square root of 3 equals x. Dunzos. Okay? So that's 3.2 in a nutshell. Due dates for the 3.2 big ideas are online. Just follow whatever they say. And I hope things are going well. Hopefully you're helping each other out. Any major questions? Miss Giabardo is the other Honors Algebra 2 teacher, and you can always go to her for help, or really any math teacher. They know what's going on, okay? All right, thanks for watching. Good luck.